lecture we will discuss some numericals based on moment of inertia. We will basically discuss two methods. In first numerical, we will discuss the moment of inertia about centroidal axis, about horizontal centroidal axis as well as about vertical centroidal axis. And in the second numerical, we will discuss the moment of inertia about any other axis except centroidal axis. So let us see in this numerical. You can see we have to find Ixx and Iyy for the T section shown in the figure. Okay, now what is T section? In this T section, first rectangle part 1 is horizontal like this and second rectangle part 2 is vertical like this. The distance is shown over here. The width of this bottom rectangle is 20 mm and vertical height of this rectangle is 60 mm. Y bar equal to 50, X bar equal to 30. Actually, X bar and Y bar we will calculate. It is given in the figure directly, though it remains to calculate in this numerical. Now, this horizontal length is 60 mm for the upper rectangle and vertical height is 20 mm. Now, as the section is symmetrical about y axis, we can say that X bar equal to 60 by 2 equal to 30 mm, means total width by 2 equal to 30 mm. This method we have already discussed in center of gravity. Now let us talk about part 1. For the part 1, this part area will be 60 by 20. So A1 equal to 60 into 20, 1200 mm square. Now what is Y1 actually? Must see. For Y1, you have to take a reference of bottom axis, which is X axis. Now part 1, CG will be at the center. From this center, the vertical distance is 10 mm plus 60 mm. So it will be 70 mm. So 60 plus 10 equal to 70 mm. So it is Y1. This method is repeated as in CG. Part 2. Part 2, vertical height 60 and horizontal width 20. So 60 into 20, area will be 1200 mm square. Now what is Y2? For part 2, CG will be over here, means at the center. From the center up to the bottom, it will be half of 60, means 30 mm. Now what is the formula of Y bar? It is as usual A1 Y1 plus A2 Y2 upon A1 plus A2. So by replacing the values in the formula, you will get Y bar is equal to 50 mm. So hence we have calculated X bar is equal to 30 mm and Y bar is equal to 50 mm. But this is the first method. First method means what? We have to calculate, as you can see in the question, Ixx and Iyy. Must remember this. When we have to find Ixx and Iyy, then and then we will find CG, means X bar and Y bar. But we will see in the second numerical that if the moment of inertia is asked about any other axis except Ixx and Iyy, then we will not find CG. We will directly calculate the moment of inertia. So find CG when Ixx and Iyy has been asked. Don't find CG when any other axis has been asked. Okay, so must remember these two fundamentals. Now let us discuss moment of inertia about centroidal axis. So you can see now what is given in the figure. The same figure, we will first of all find Ixx for part 1. As per parallel axis theorem, Ixx means this is the Ixx, centroidal axis. About this axis we are going to find moment of inertia. Now what is Ig? Ig means moment of inertia about this axis for part 1, means centroidal axis of part 1. Then H will be distance between these two axes as shown in figure. Distance between these two axes. Which two axes? About centroidal axis Xx and about centroidal axis of part 1. So distance between these two axes is known as H. A means area of part 1. So let us start. Now what is the formula of Ig? It is BD cubed by 12. When it is Ixx, it is BD cubed by 12. When it is Iyy, it is DB cubed by 12. You can see in the formula. So B means width 60, D means depth 20. So 60 into 20 cubed by 12. Now what is area of the rectangle? 1200, as you can see in the calculation of CG. Now must remember what is H bar. You can directly see from the figure, this is totally 20. So this vertical distance is 10 plus this distance we have to calculate. Now y bar is equal to 50. So this centroidal axis will be at a distance of 50. This distance is 50 and total is 60. See in the figure, total is 60. So this is 10. So answer will be 10, 10, this 10. Remember this. This is 10 and this is also 10. So total 20. But by this drawing or by this calculation, the figure will become very tedious. So we have calculated the shortcut method. Now h is equal to y1 minus y bar for part 1 and h is equal to y bar minus y2 for part 2. You will get the same answer. So what is y1 minus y bar? That you can calculate from the table. y1 is 70, means distance of CG of part 1 from the bottom axis, and y bar is equal to 50 as calculated earlier. So this is h, 70 minus 50 whole square. By simplifying in your calculator, 5.20 into 10 raised to 5 is the answer of moment of inertia. Unit will be mm raised to 4. Now for the second part, Ixx equal to Ig plus A square. Now for the second part, what horizontal width means B means 20, D means 60. So 20 into 60 cube by 12. Area same 1200. H bar is equal to y bar minus y2, which you can find from the table. So 50 minus 30 whole square. Answer will be this. Now these are the separate formula for Ixx and Ixx1 and Ixx2. But we have to calculate Ixx for the entire section. So Ixx for the entire section will be Ixx1 plus Ixx2. So adding these two values, you will get Ixx is equal to 13.6 into 10 raised to 5 mm raised to 4. So this is the method to calculate Ixx. Remember this thing, in Ixx we are using y bar minus y2, y1 minus y bar, etc. because it is x axis. So it is vice versa. When you will find Iyy, then here it is x1 minus x bar, x2 minus x bar. Okay, let us see how we can calculate Iyy now. So in the same figure, this is the calculation of Iyy now. You can see from the figure Iyy1 and Iyy2 we will calculate separately with the help of parallel axis theorem. While calculating Iyy, what is Ig? So formula will interchange the value. It will be dB cube by 12. Okay, so what is dB cube by 12? This is dB cube by 12. You can see in the part 1, depth is 20 and B is 60. So dB cube by 12 means 20 into 60 cube by 12. Area will be 1200 and h will be 0. H will be 0. How h will be 0? Because the figure is symmetrical about y-axis, you can see x bar is equal to 30 at this distance and x1 is also at the same distance. So x1 and x are both are same. So if you find h by means of x1 minus x bar, then it is 30 minus 30 will become 0. In short, forget this thing, just remember shortcut that when the figure is symmetrical about y-axis, then h is always 0 for all the parts. Again repeating, when the figure is symmetrical about y-axis, then h will be 0 for all the parts. So for the part 2, it is 60 into 20 cube by 12 plus 1200 into 0. For part 2, depth is 60 and width is 20. So by calculating, first value will be 3.6 10 raised to 5 and second value will be 0.40 10 raised to 5 mm raised to 4. We are wanting to calculate Iyy for the entire section. So Iyy for the entire section will be summation of Iyy1 and Iyy2, means addition of moment of inertia of part 1 and part 2. So by adding part 1 answer and part 2 answer, you will get total Iyy of the section. So basically this is the method of calculating moment of inertia about centroidal axis xx and yy. But what if the moment of inertia is asked about any other axis? Let us see in the next example. In this example, you can see we have to find IAB for the section shown in figure. Where is IAB? Actually, AB is this axis given to you. Means AB, the axis which is already given in the figure, then you have to calculate IAB directly. Means you don't have to find CG itself. Do not find X bar and Y bar. Just directly go to the formula. Now, here we are using shortcut formulas. One formula for the semicircle. There is no theory for the semicircle in our syllabus, but you just remember the formula of the semicircle directly. Let us see how. First of all, moment of inertia of a triangle. Now, must listen to me, my words, each and every words. This axis AB, about which we have to find moment of inertia, is also the base of the triangle, is also the centroidal axis of the circle, is also the base of semicircle 2. Okay, it is also the base of this semicircle, means this is the base of semicircle, you can say diameter. So when these things are happening, these things means what? When the given axis AB is base of the triangle, centroid of the circle, base of the semicircle, then we will use direct formulas. We will not use parallel axis theorem in this case. So we will use direct formula about the bases. So according to formula about base, triangle's moment of inertia will be bh cubed by 12, where b means base of the triangle, this, which is equal to 40 plus 40, 80. And h means height of this triangle, which is also 80. So 80 into 80 cubed by 12. So answer will be 3.41 into 10 raised to 6 mm raised to 4. Now moment of inertia of this semicircle will be equal to pi by 128 d raised to 4. Remember that formula for the circle is pi by 64 d raised to 4. So for the semicircle, formula will be half of the circle. Means what is half of the pi by 64? Remember, what is half of the pi by 64? It is not pi by 32. It is actually pi by 128. Okay, 64 into 2, pi by 128. So pi by 128 d raised to 4, where d means diameter of the semicircle, which is again 80 now. So pi by 128 into 80 raised to 4, you will get 1.01 into 10 raised to 6. For the part 3 means circle diameter is 40. So pi by 64 d raised to 4 is the formula, where d equal to 40. You will get the answer 0.125 into 10 raised to 6 mm raised to 4. So moment of inertia will be IAB equal to this. Now this means what? Part 1 plus part 2 minus part 3. Remember the circle, see in the figure, the circle is cut out from the section. The section is composed of triangle, then semicircle at the bottom, and from this two combination, circle will be cut out from the section. So circle will be negative. So by replacing all the values, you will get the answer of IAB 4.295 10 raised to 6 mm raised to 4. Remember this thing, in the moment of inertia, you have to do the practice. You have to do practice very well in the calculator. So this is the tough calculation in the calci. So these are the basic two methods of calculating moment of inertia. First one is moment of inertia about centroidal axis, and in the second sum, moment of inertia about any other axis which is not given to you, but it is always shown in the figure. Okay, so both the methods are different to find moment of inertia. So we will conclude the topic over here. So this is the syllabus of your mid-sem exam. So thank you very much. Go through all the videos, practice yourself from lecture number 1 to lecture number 32, and ask for any doubts. Thank you and best of luck, students.